If you are new to the channel, then subscribe the channel and press the bell icon for further notification. Okay student, welcome you all to this new lecture on gate analog electronics. So today we will be solving 5 questions from question number 96 onwards, 96, 97, 98, 99 and then 100. Okay, then let's try to solve these questions. Okay student, if you come to question number 96, then what here they are asking. The op-amp shown in the figure has a finite gain. Now they have given a finite gain. It is not an infinite gain op-amp. Okay. A is equal to 1000 and an infinite input resistance. Input resistance is infinite, that's okay. A step voltage of Vi is applied to the input voltage at t equal to 0 as shown in the figure. Assuming that the operational amplifier is not saturated, it is not saturated, the time constant of the output voltage V0 is equal to. Now you cannot say here because it is not infinite gate. What we thought in case of negative feedback, in case of ideal op-amp, this potential equal to this potential. That we always assume in case of negative feedback if it is ideal op-amp. Why this is so, I have explained, because we thought that the gain was infinite. But because gain is finite here now, so we cannot do this one. So this is 0, this will not be 0 here. This will be some voltage, okay. And the difference of these two will get magnified by this gain. That is A. So if you draw your figure will look like now. Suppose this is a potential now VA. So this will be a potential VA and this is at 0. So what will be output? This V0, you can write it now. Because this V0 will be the difference of this will be multiplied by 1000. So what you will do? So your V0 will be equal to 1000, that multiplied by 0 minus the non-inverting minus inverting. So this is your V0. But this is coming in terms of VA, you need it in terms of VI. So for that you can apply nodal at VA. At this point you can apply nodal so that you can find the relation between VA and VO, VA and VI. So you can find then, finally you will get relation between VI and VO. So if you take nodal, it will be VA minus VI divided by 1000 plus VA minus VO divided by 1 by CS. I am doing it in Laplace, 1 by CS. That is equal to 0. If you put it here, this value, then final expression you will get it something of this fashion. V0 S plus S by 1000 plus 1 is equal to minus 1000 Vi, which means your V0 by Vi will be, it will be 1000 minus 1000 by 1.001 divided by S plus 1 by 1.001. Now how does this signal look like? Because I need only time period, so it will be 001 e to the power minus t by 1 by 1.001. So it was t by tau. What is the time constant? It is e to the power minus t by tau. So this is the time constant tau, 1 by 1.001. That is your 0.999, which is nearly equal to 1. That is your option D. So you have to be very careful about. Till now what we have done, in case of ideal it was infinite, so this potential was same. But here, because it is given, so it will not be same. Now the saturation voltage of an ideal op-amp shown is plus minus 10. The output voltage V0 of the following circuit in steady state. So now what you will do, this one you can see as it is given in both side negative positive. This one you have already seen, and this is a capacitor, so this voltage will be continuously charging and discharging. So it is a comparator basically. Some portion of output is taken, now it is compared. If it is greater than this, then it will go to minus 10. If this is greater than this, then it will go to 10. So this type of circuit we have seen where both the feedback is there. Feedback is also there and some output portion is also taken. So it is nothing but a comparator, and this path is given for discharging the capacitor. That's it. Okay. Now that means it will be either plus 10 or minus 10. That means it will be a square wave. That is for sure. That means B and D will not be the answer. It will be either B and A and C. Now they are asking the time period. Time period means they are asking this one. Suppose it is of this square period. Suppose if I take one particular period here to here, then what will be the time period it is taking. So it will be symmetry. If you can calculate half, then next task will be same. Okay. So for this starting, suppose it is just now switched on. Just switched on and it is at 0 voltage. Suppose for the starting it is V0 is equal to 12 volt plus 10 volt. It is at positive saturation. You can start with minus also. In that case you will start with this. That is no issue. But I am starting with this signal. Okay, whatever. So let us think that for the very beginning it is started with this condition, that is V0 is equal to plus 10. This potential, then what will be this potential? Suppose we have to name it now. Suppose I am writing it V plus and that potential V minus. What is the potential at plus terminal? It will be, you can see, half of V0. 2 kilo ohm, because V0 is divided. You can take KCL here, nodal here. V plus minus 0 by 2, V plus minus V0 by 2 will be equal to 0. But no need, because V0 is divided into two parts. So this is the lower part. So it will be half of this, because it is equally divided. So it is V0 by 2. So this potential is at 5 volt. Okay. Now this potential is at 5 volt. Now think about capacitor. The capacitor will get charging initially, because you have, what is the circuit now looking like? You have a capacitor here, you have this one, and you have a voltage source here. So you have something of this fashion. You have a voltage source of plus 10 volt. This was our consideration V output. So you see this path. This is the return path earth. You can see this path. So this is the path through which the capacitor will get charged. So this is also earth. This is also this is the return path, and through this path it will get charges. Okay. So once it gets charged, how it will get charges? Because current will flow in this direction, and it will be plus, it will be minus. This potential will come here. Okay. So what is the because this potential, what is B minus? B minus is nothing but VCT, the potential of capacitor. Okay. Now if it is a charging mode, then what will be its the expression? So what is that Guru mantra, that good mantra that we have studied? It is Vc infinity. What is the infinite voltage? If you keep it on for infinite time, finally its potential will be equal to this potential. No current will flow. It will get fully charged. So final voltage is 2. What is initial voltage? 0. Final voltage is 10 e to the power minus t by Rc. What is Rc here? R is given 1 into 10 to the power 3. What is C? 0.25 into 10 to the power minus 6. So if you do, it will be 4000 T. I am directly writing it 4000 T. You can do it, it will be 1 by 4000, and if you do it, it will be 4000 T. Okay. T into 4000. Now this potential, because it is rising, this potential is rising. When the switching will occur, when this potential will be greater than this, when your V minus will be greater than V plus, then this transition will occur. From plus 10 to it will go to minus 10. From plus 10 it will go to minus 10. Okay. So this transition will occur when it is from plus 10 to minus 10. So when this transition will occur, when this potential is at 5 volt. Because V plus is already at 5. So if your V minus, this potential is greater than 5 volt, it is already at 5. If you can make it more than 5, then the transition will occur. It will go to minus 10 situation if this is higher. So when this will be more than this, let me see when it is equal to 5. So 10 minus 10 e to the power minus 4000 T. So if you solve it, you will find that T equal to 1.732 into 10 to the power minus 4 second. At this second, this is not the answer. At this second it will switch. At this second, but you don't know from what time it started, because you thought that it is at 0 initial condition and that you started. So from here onwards, the circuit will be now a smooth circuit. Because it is initial circuit, now the circuit just started operating. So it will be first swing. Next you have to see next swing is when. So next swing is when, after, because it will be charged up to 5. Once it gets charged beyond 5, then it will be minus 10. Then it is minus 10 means it will start now discharging. So it will be just 5 and then less than 5. 5 then less than minus 5, because it starts when it get minus 10, then this potential is minus 5. So when the charge will fall minus 5, then only it will go to again plus 10. So here the capacitor voltage should be less than 5, then this will occur. Here the capacitor voltage, this transition when it is from minus 10 to 10 must be less than minus 5. You see, if it is less than 5, then it is going to, because this potential is, if it is greater than 5, doing every time mistake. If it is greater than 5, then it is going to minus 10. If it is at minus 10, then what potential you will get? You will get now minus 5. Now when the transition will occur, when the capacitor discharge and goes its value below minus 5, then this will at higher potential, then it will go to plus 10. So next switching will occur. So the capacitor will be between plus 5 and minus 5. It will be between these two only, between plus 5 and minus 5. So this initial, just we thought, we don't know from where to start, that's why we started. So this is not the answer, this is not the time period, because you don't know the first switching. We have not done the switching, we have just started from any initial condition. Next it is starting a smooth one, it is switching. So you remove that first part is our consideration only, we started from any point. Then you for time period you calculate next period. First transition you have occurred here, next transition you see when it will occur, because now it is, the circuit is in rhythm now. So it will start following your basic property. So when you switched it on at t equal to 0, suppose, with a V out equal to 12 volt. So after 1.73 to whatever time we calculated, it switched to minus 10 now. It will switch to minus 10. Okay, now if it is at minus 10, that means your V plus is at V0 by 2, that is your minus 5 volt. Now next switching when will occur? When V minus is less than minus 5. Now what is the circuit is looking now? Now the circuit is looking of this fashion. This plus minus will go now. Now this will be, because it is minus 10 now, so this is now minus 10. So it is minus 10. So this is grounded now. So it is, you see the negative terminal is here. Now the capacitor, initially it was getting charging in this condition. Now capacitor will not go in this direction. Now what will be the direction of the capacitor? Now capacitor will start discharging. Now because capacitor voltage is higher, what is the capacitor voltage? It is plus 5. And here it is minus 10. Now it will go discharging. Now this is the path for discharging. Now again, what is the equation for discharging now? Again that great formula will start. What is the final condition? If you continue this circuit for infinite time, what will occur? This potential will be same as this potential. No current will flow. So this is at minus 10. So this will be at minus 10 only. If you think about this direction, so this is at minus 10. So this potential will get, this terminal will get plus 10 and this terminal will get 0. You can think. So whatever we thought it is plus minus, so it will be just opposite to that one. So it will be minus 10. So this is the final. What is initial? Initially it was at plus 5 volt. What is final? That is minus 10. E to the power minus t by RC is again same line, same path. So R and C remain same. So it is 4000. So when the transition will occur? When it is at minus 5. Now if you solve it here, you will find t equal to 2.74 into 10 to the power minus 4. So now you see this transition. From here to here, this transition will take this much second. Now you can say, okay, if this transition is because it will be symmetry, so next transition will be same after this much time. Now every transition will be after this much time, because circuit is now its own rhythm. Initially initial condition was just starting condition. You don't know from which position it started. When this switching occurred, you don't know. When it came to plus 10, you just started with plus 10. So this will be clear because it is starting from minus 10 to plus 10. Plus 10 to minus 10, then again from minus 10 to plus 10. So one complete switching from here to here, one transition. So you completed the transition portion. So what is the time period from here to here? So your time period will be 2 times of this t. So if you do 2 times of this one, it will be 0.55 millisecond. A. The filters F1, F2 having characteristics shown in the figure is connected in the shown in the figure. So one filter is connected here, one filter is connected here. Okay. What is this circuit? This circuit is a standard feedback. So what you will do, this voltage is equal to this voltage, no current is flowing through, so VI, so your VI will come here, so this is VI. So you can still say VI is equal to V0. So your V0 is equal to simply VI, because if you take nodal here, no other branches is there. So VI minus V0 by R by 2 equal to 0. So V0 equal to VI. So from this circuit it is equal to VI. Whatever you give, it will come directly here, and it will be positive. There is no negative feed because it is at non-inverting terminal. So whatever input get, that will come out. Okay. Now if you see, F1 is less than F2 they have given. So this is F1 is less than F2. So if you merge these two, your circuit will like this. This is your F1, okay, and next this is your F2. So because your F1 is less than F2, it will look like this. If you combine these two, this is your question number 19. Okay. The resultant circuit will exhibit a characteristics. What will be its characteristics? So when you give supply, something below, all below F1 frequency will pass. That will come in the output. Okay, this will come in the output, and this will come when you give F1. Okay, when you give, because both you are giving, so F1 will give up to this much. So these all will come, and F2 will give signals above this one. So this will also come in the output. So your output will look like something of this coming and then something, so it will be of look this type. So a particular band from here to here, F1 to F2 will be rejected. No signal between these two will come out. So it will be a band stop filter or band reject filter. That is your option B. You can see anything below F1 will be passed through F1. So if it is passed through F1, then F2, F0 will come. Anything above F2 will pass through this path and it will come in the output. So these also will come in the output. So middle portion will not come because no one will allow anything between this F1, F2 frequency. So this particular period, this particular frequency band from f1 to f2, this band, we are saying band means range, that will not be allowed to pass on, that is band stop or band reject. Of the four characteristics given below, which are the major requirements for an instrument amplifier? So that you can think of op-amp, what are the op-amp ideal characteristics, that's it. What new op-amp will need, ideal characteristics. High common mode resistance, that's we always need, because we need to gain, amplify that gain V1 minus V2, that should be very high. So that is your gain only. So in common mode rejection CMMR should be high. High input impedance, high linearity. Linearity means your input, if you increase output, linear relation will be there. High output impedance, that is not okay. How high output will not give you significant answer, because you see why it is high input resistance, because it is amplified. That means you are giving a small signal. What is your input output look like? If you give input, this is my input Vi, so input resistance is look like, and this is my output V0 I0. So output I will be connecting something, and here I have connected already something. So that is the difference. Here you have already connected in this terminal, and you are getting output and you are connecting it. Okay. So because the signal strength is very small, so you need the full voltage should come here. There should not be any internal drop. So if you give input impedance is very high, so current flowing will be very less, the whole voltage will come here. So you will get the full signal, because your signal is weak here. You need to magnify, amplify the small signal into a high signal, high one. And in the output you don't need any, you don't want to have any high output impedance, because if you connect, current will start flow. So if there is internal impedance very high, then all drops will be there, nothing will come out. So for everything should come out, there should be zero impedance. So whatever it generated, it should come out whenever you connect a load there. So that's why it should be low output impedance and high input impedance. So there is a difference. In input you have already connected something, in output you are supposed to connect. So when you are supposed to connect, you need internal resistance should be zero. When you have already connected, you need internal impedance should be infinite, so that full thing should come here. No significant, all the drops, all this should come here. Input voltage should come here. So input impedance should be always very high, and output impedance should always very low for an amplifier to work out. So that means your P, Q and R only. So that is option A. Now if you see question number 100, what they are asking here, the circuit shown in figure below is a low pass, high pass, band pass. Again what we will do, because it is just we need to just say which type of filter we will take, R11, R21, C1, and then we will try to find the equation. So because it is a negative feedback and think nothing is saying, you think this is an ideal op-amp, so it is 0, this is 0. So if I take nodal here, 0 minus V in by R1 plus 0 minus V out by this one R2, R1 I have considered 1, R1 1, R2 1, all are 1 ohm, capacitor is 1 farad. Suppose you take this one, then it will be 1 in parallel with CS, 1 by CS, 1 in parallel with 1 by S. So what will be this one? 1 into 1 by S by 1 plus 1 by S. That is 1 by S plus 1. So 1 by S plus 1, that is equal to 0. So if you not do this one, you will find V in by V1 is equal to minus 1 by S plus 1. So what you will do, because omega should be in the denominator, it is already in the denominator for checking low pass, high pass. So it is J omega plus 1. Otherwise I should have divided, if there is S in the numerator, you divide by S in numerator denominator, because you need to bring that omega here. Now you put omega equal to 0 and calculate low pass, you read omega equal to infinity and calculate high pass. So for omega equal to 0, what will be the gain? Gain is equal to 1. What will be the omega equal to infinity? Gain. If you give infinity, this is 0. For it is, so it is not allowing high frequency, it is allowing low frequency. So it is a low pass filter. So it is option A. If you like the video, then press the like button and please give your valuable comments in the comment section.